Look at your hand, flex your fingers. What are they made of? Skin, bone, muscle, blood, molecules, and beneath that, atoms: carbon, oxygen, nitrogen, calcium. But where did these atoms come from? Their story is written in the stars. Every atom in your body, except for the most ancient, hydrogen, was forged in the heart of a star that lived and died long before our sun was born. You are not just living on Earth, you are made of recycled stardust. This isn't poetry, it's scientific fact. The universe began with only hydrogen, helium, and a trace of lithium. Everything else, the elements that make up you and your world, had to be created in stars. Stars are immense nuclear furnaces, transforming simple matter into the building blocks of life. Our connection to the cosmos is intimate, it's in our DNA. The iron in your blood was created in the core of a dying star, then scattered across the galaxy in a violent explosion. The calcium in your bones followed the same cosmic journey. We are the living legacy of stellar evolution. The universe is not separate from us. We are the universe experiencing itself. When you look up at the night sky, remember you are not just an observer but a participant. Each star is a potential ancestor in the grand story of cosmic creation. The universe's story of birth, life, and death is happening within you. The atoms that make you have traveled through interstellar space, witnessed the birth and death of suns, and finally came to rest here to form you. You are a product of cosmic history. The next time you gaze at the stars, remember you are looking at your own cosmic family tree. We are all of us made of stardust. Our story begins in the cold, dark voids between the stars, vast clouds of gas and dust called nebulae. These clouds, mostly hydrogen, drift for millions of years, the raw material for new stars. A disturbance, a shock wave from a supernova or a passing galaxy, triggers regions within the nebula to become denser. Gravity takes over, pulling gas and dust inward, slowly forming a clump. As the clump grows, its gravity strengthens, drawing in more material. The collapsing cloud heats up, glowing faintly red. A protostar is born. It's not yet a true star, but it's on its way. A disk of dust and gas forms around it, the birthplace of future planets. At the core, temperatures soar to millions of degrees. The stage is set for a dramatic transformation, the moment when the protostar ignites and becomes a true shining star. This is how every star, including our sun, begins its life. Deep in the protostar's core, nuclear fusion ignites. Hydrogen atoms fuse into helium, releasing immense energy. This energy pushes outward, balancing gravity's inward pull, and the star becomes stable, a main sequence star. Our sun has been in this phase for 4.6 billion years, shining steadily. Energy created in the core takes thousands of years to reach the surface, finally radiating into space as light and warmth. This fusion process powers nearly all life on Earth, driving weather, photosynthesis, and the food chain. The sun's long, stable life has allowed life on Earth to evolve and flourish. Every time you feel the sun's warmth, you're touched by energy born deep within its core. The star's steady light is the foundation of our existence. Not all stars are created equal. A star's mass at birth determines its entire fate. Massive stars burn hot and bright, using up their fuel quickly and living only a few million years. Smaller stars, like red dwarfs, burn slowly and can live for trillions of years. Our sun is in the middle, bright enough to warm planets, stable enough to last billions of years. Mass dictates a star's temperature, color, brightness, and lifespan. Massive stars are cosmic rock stars, living fast, dying young. Red dwarfs are the slow burners, shining faintly for eons. Our sun's moderate mass gave Earth the time needed for life to evolve. The long, stable life of a star like the sun is rare and precious. Without it, complex life would never have had a chance. Mass is destiny, and our sun's mass was just right for us. The story of life is written in the stars. For a star like our sun, the end comes quietly. After billions of years, its hydrogen fuel runs out. The core collapses, the outer layers expand, the sun becomes a red giant. Helium fuses into carbon, but soon even that fuel is gone. The outer layers drift away, forming a glowing planetary nebula. A star's final sigh. What remains is a white dwarf, a dense, hot ember about the size of Earth, slowly cooling over billions of years. Eventually, it will fade into darkness, a black dwarf, a silent remnant of a once brilliant star. This gentle end awaits most stars in the universe. Even in death, a star returns its material to the cosmos. Yep. For massive stars, the end is explosive, a supernova. These stars burn through their fuel quickly, fusing heavier and heavier elements until their cores are iron. Iron can't release energy through fusion, so the core collapses in an instant, triggering a titanic explosion. The supernova outshines entire galaxies, scattering elements across space. What's left behind depends on the star's mass, a neutron star, an ultra-dense city-sized sphere, or if massive enough, a black hole, where gravity is so strong not even light escapes. Supernovae are the universe's most spectacular events, both destructive and creative. They forge new elements and seed the galaxy with the building blocks of planets and life. Without supernovae, the universe would be a much simpler place. These explosions are rare, but their legacy is everywhere. The story of creation is written in their violent glory. Stars fuse hydrogen into helium and giants fuse helium into carbon. But where do the rest of the elements come from? In the heart of massive stars and their explosive deaths, elements up to iron are forged. The supernova explosion itself creates all elements heavier than iron, gold, platinum, uranium, through a frenzy of nuclear reactions. These elements are flung into space, enriching the galaxy. Without supernovae, there would be no rocky planets, no life, no gold or iron. The iron and steel, the gold and jewelry, all were born in the heart of a dying star. These atoms traveled across the galaxy before becoming part of Earth. We are surrounded by and made of the legacy of these stellar explosions. The universe's diversity is the gift of dying stars. The death of a star is not an end, but a beginning. Elements forged in stars and supernovae enrich the galaxy's gas clouds. These clouds become the next generation of stellar nurseries, giving birth to new stars and planets. Dust grains stick together, forming pebbles, rocks, and eventually planets. Closer to the star, rocky planets like Earth form. Farther out, gas giants take shape. Our solar system was born from such a cloud, enriched by ancient supernovae. The iron in Earth's core, the water in our oceans, all recycled stardust. Our planet is a second-hand world built from the ashes of ancient suns. The story of the cosmos is our story. The elements forged in stars became the building blocks of life. Carbon, oxygen, nitrogen, calcium, iron. These atoms traveled across the galaxy, became part of Earth, and through biology became part of us. You are a living collection of stardust, billions of years in the making. We know this because we've learned to read the universe using telescopes, spectroscopy, and meteorite analysis. Science reveals our profound connection to the cosmos. We are not separate from the universe, we are a way for it to know itself. This knowledge brings wonder and responsibility. We are custodians of ancient atoms. The next time you feel small, remember you are connected to every star in the sky. Stay curious, keep looking up, ask questions. The universe is full of wonders, and the greatest wonder is that we are here to appreciate it. We are all of us made of stardust. The universe's story lives within us.